All right, guys, we're going to go ahead and jump into this. We're going to be looking at atoms, just kind of getting you guys ready for the quiz, making sure that you are ready to score really well. So the first thing to kind of understand here is that atoms are incredibly tiny. If you look at this little image here, it says if an apple was magnified to the size of the Earth, the atoms in the apple would be the same size as the original apple. So basically, if you were to take this Earth and you were to fill it full of apples, then what you would see would be that they would be the same size as an atom. So what does that mean for you? It means that on the tip of your pencil, you could fit thousands and thousands of atoms. If we go forward here, you can see that we have the charges of the particles, and we're certainly going to be asking you about this on your test. So the first thing to know is that electrons are negative, and we always want to write the symbol for electrons with a lowercase e just to show that they're very small. Protons are positive, and neutrons have no charge. You put like a little zero there. So when we talk about protons, neutrons, and electrons, just understand that they all have their own individual charge. The reason that protons and electrons will stay close to one another is because they're attracted because they are opposites. Here's a great example of an illustration of an atom. Take a moment real quick and I want you to pause and I want to ask you, what element are we showing here? What element is this? And you can use your periodic table to try to find that. If you look, you'll notice that you actually have 3 protons. And the number, like the atomic number, is always going to be equal to the number of protons. Now for us, we also want to say that it's equal to the number of neutrons and electrons, but a hard rule that we have in science is that protons are always equal to the atomic number. They are always equivalent. So if you look at your periodic table, what you will find is that this element is in fact lithium. You know that because you have 3 protons and the atomic number is 3, and when you look on the periodic table, number 3 is in fact lithium. Here we can see some what we call isotopes. And the reason I wanted to show you this originally is because I wanted to show you that this mass for carbon can be different. Even though when you find carbon, you're always going to have 6 protons, you can see here that even, I just suggested to you that you should also have 6 neutrons, which is definitely true for carbon-12. However, sometimes the number of neutrons can be more or less. Okay, so going back to my previous slide, I told you that the hard rule in science is that the atomic number is always equivalent to the number of protons. However, it's not necessary that it's the number of neutrons and electrons, but it sometimes is. So here you have an example where you have 1 extra neutron for carbon-13, and for carbon-14, you're going to have 2 extra neutrons. But I just wanted to show you that to illustrate a couple of things. Number one, the fact that we can have a variant number of neutrons. But number two, how we find the mass of the atom. Because this number is actually called the mass number. And so the mass of the atom is always going to be the protons plus the neutrons. We do not count the electrons because they are very tiny and their mass is negligible, which means very small. What we have here is we have an element. We have some elements. Right here we have chlorine and we have sodium. And over here we have a compound. This is a molecule of the compound known as sodium chloride. Now, the one fact that I want you to glean from this is that the chemical and physical properties of the elements are different from the compound that they form. So let's just take a second to look at this. When we look at chlorine, chlorine is poisonous. It is poisonous. Sodium is highly reactive, as well as chlorine. It's also highly reactive. However, when we look at salt, which is sodium chloride, we see that this is a white crystal, and it is non-reactive. As a matter of fact, you eat this in the cafeteria. So the point here is that these elements are very different from the compound. Even though they're made from the compound, it's made when the chlorine and the sodium, they bond together. The properties are extremely different. It's not the same at all. They have no similarities. As a matter of fact, chlorine is a gas and salt is a crystal. It's a solid. So they do not look alike. They do not behave the same way. They do not share those properties whatsoever. And if you didn't know better, you would have a hard time knowing that they come from one another. We can see here what happens when sodium and chlorine bond together. So what do you notice about this image? What do we see that's going on here? And the second part of the question is, what's really involved in them coming together? So from the illustration, what you are seeing is that there's an electron over here, and it's sliding over there to connect with the chlorine. And so because of that, what we can see is that all of these reactions are caused by electrons. All the reactions are caused by electrons. And it's not all the electrons that are part of this reaction. It is specifically the electrons on the outside. So these electrons on the outside have a special name. You don't have to know it for the quiz, but I'm going to go ahead and throw it out there. These are called valence electrons. And the word valence just means outside. So the electrons that are on the outside are the ones that cause chemical reactions. Many of you in class have been able to tell me that they are chemically bonded or chemically combined. And so what that means is the electrons do something to lock these atoms together to form a compound. Okay, so a chemical bond is always going to be brought about by electrons doing something to cause that. And that's something we're going to touch on later, but I did want to go ahead and throw it out there to you. So looking at the periodic table, we can tell a lot about an atom based upon where it is placed. So if I want to know how many electron circles to put around the outside of an atom, I'm going to simply look at which row it's in. Now, each of these rows is called a period. And remember that these elements down here actually go here, and then this one goes here. And if you notice that atomic number kind of jumps up a bit, that's to account for all of these in the rows. But we don't need to worry about these right now because they're not very important to us. As a matter of fact, these don't last very long. As soon as you make them in a laboratory, they're all man-made and synthetic. But as soon as you make these in a laboratory, they will begin to break down. So they don't last very long. And so we don't really need to focus our time on them. But if we look up here, what we can see is that this row is going to tell us how many electron energy levels to draw. So if I'm trying to draw a model of, say, helium, it is going to have 1, 2 protons. Let me go ahead and switch colors for you and switch to orange. It's going to have 1, 2 neutrons. And then when I draw the circles going on the outside, I'm only going to draw 1. And to make sure that I'm balanced, I don't have to be, but I want to be right now, I'm going to go ahead and draw 2 tiny negatively charged electrons. Let's see if I can draw that. There we go. Put one there, I'll put one there. All right. So the point I want to make here, though, is this. Because helium is on the first row, it only has 1 electron circle. If I look down here at potassium, potassium is on the 4th row, so you're going to have 4 of those electron circles. And we have a name for those electron circles. We call those energy levels. Energy levels. So let's look at an example of how we could kind of use this information. We go back to lithium. Now, at the beginning, we kind of talked about how lithium was atomic number 3. So we're going to go ahead and draw 3 protons for lithium. And now we'll draw 3 neutrons. If I look at the mass number, it says 6.9, which could round to 7. So we know we could have 7 here if we wanted to. But we know that sometimes it has 6. So we want to go ahead and do 6 total particles. Again, that's the protons plus the neutrons. Okay. I want to go ahead and just draw 6 total instead of 7 because I want to keep it. I want to keep it balanced. I want to keep it the same. But I could draw 7. That's totally fine. What matters is I have 3 protons. Okay, because that's what identifies the atom. And remember, those protons have that positive charge. All right. Now, drawing the electron circles. If you look at your periodic table, you'll see that lithium is actually in the 2nd row. It's in period 2. So I'm going to draw 2 of these circles. And I'm going to go ahead, I'm going to place 2 of my electrons here. There I go. And I'm going to place 1 on the outside. Now the reason for that is because electrons, if you play around with a magnet, what you're going to find is that if you put 2 north poles together, they will try to push away. The same thing is true with electrons. If you put 2 of them together, they're going to try to push away from each other because like charges repel, different charges attract. And that's why the protons can hold the electrons in place because they're opposites. The 2 electrons are going to push away from each other because they're the same. And because of that, we can only put 2. We can only put 2 in this first circle. That can only hold 2. Now the 2nd circle can hold up to 8. But with lithium, we only have 3. We don't have to fill this up to 8. We only need to place 1 more here in this outside circle because we need a total of 3. And as you can see, 2 plus 1 equals 3. So that's how you would draw this. You would put 2 on the first circle and then 1 on the outside circle. All right, let's go ahead and go to boron. Boron is number 5 on the periodic table. It's also in that second. It's also in the 2nd row, just like lithium is. So when I draw boron, I want to go ahead and start with 10 particles because the mass of this is 10. So and I'm going to make 5 of those positive because the atomic number is 5, and I need 5 protons. All right, now I can place my 2 energy levels because, in fact, if you look at boron on the periodic table, you'll see that it's in the 2nd row. So I place my first circle. Remember that I can only hold 2 here. And then I go ahead and I go with my 2nd circle. And if I want to be balanced, I want to have a total of 5 of these, just like I have 5 protons. So I'm going to go ahead and I'm going to add 3 more. Remember, this 2nd circle can hold up to 8, but I don't need to place all 8. I just need to place 3 because 2 plus 3 is 5. And now this is balanced. Again, I'm drawing this the same way. One thing I want to say here is that, just like I can have a different number of neutrons, I could have a different number of electrons. That happens all the time. But for this example, I'm not going to do that. And you can see boron is right here. That is the 2nd row, just to show you. If you wanted to draw sodium, you would have 3. If you wanted to draw potassium, you would have 4. So just know that this row is going to correspond with those electron energy levels. And here I have a little illustration to help you remember that. When we talk about something like helium, helium is in the 2nd period. Remember that it's small, like the little teddy bear. The teddy bear has 2 feet. So remember, the first circle can hold 2. Whereas if you go to something like sodium, sodium is a much larger atom. Sodium is going to have a total of 3 of those energy levels. So the first level can hold 2, And this second level, just like the octopus, has 8 of these little feet, pseudopods. We're going to go ahead and place 8 on the second level of the atom. Now, I don't want to get into specifics because it's going to be a little complex for you guys at this level, but just also assume that if we have another level, it can also hold 8 for right now. But we'll get into more specifics about that later on. But for right now, just understand that that first level can only hold 2, and as you go further along, we're looking at 8. But it does get a little more complex than that when you get into higher level chemistry. But for right now, let's keep it there. And we had some questions as we finished up with our groups. If you want to go back to the yellow entry, we're going to take a moment just to address these questions quickly to make sure that we don't have any confusion. What is an atom and how would you describe it in simple terms? What we could say about that is that an atom is the smallest building block of matter that has an identity, right? Once you get below the atom, you kind of lose an identity. You could describe protons, but all protons are the same, but not all atoms are the same. Okay, so atoms behave differently based upon how many protons they have. So if you look at lithium and say nitrogen, even though they're both in period 2, they're very different with their chemical and physical properties. The 2 parts that make up an atom are the nucleus, and remember that all the mass is in the nucleus, and that's going to be your protons plus your neutrons, and your electron energy levels. What are electrons and why are they important in atoms? They are negatively charged particles. And they are responsible for reactions. All chemical reactions are from electrons. Reactions, there we go. All right, now how can you determine what type of atom an element is based on? Because the protons always equal the atomic number. So in order to identify an atom, you really can't use the electrons or the neutrons because, like I said before, like we've already shown you, those can be different. Those can be out of whack. But the protons will always equal the atomic number. Always, always. An example of a molecule and explain how it forms into atoms. So we're going to go ahead and just go with our example we had in the presentation, the sodium chloride. And sodium chloride forms when, we'll just say right now that electrons form bonds. So a molecule is going to be 2 atoms that are joined together, and it forms when electrons form bonds. This next question is wonderful. Why do electrons arrange themselves in specific energy levels or shells around the nucleus of the atom? Because the like charges repel. And you guys have probably used a magnet before and kind of tried to push it together, and you saw that it pushed away from the other magnet. But what's going on there, what's happening is those like charges are going to push away from each other. So that is exactly what's going on here, is that we have the like charges are going through a process where they repel each other. They push away. So you have negative charges and negative charges, and they don't want to go near each other. Like they want to push it away from each other. But if you had a positive and a negative, they're going to move toward each other, and that's what actually holds the electrons in place next to the protons. How do opposite charges affect the behavior of electrons and protons in an atom? They attract. They attract. Opposites attract. Again, if you think back to when you were using magnets, you can remember how they kind of interacted. So why is understanding atoms important, and how can it benefit us in the real world? Well, that's a very great answer for this question. In the article that you read, it helps us to invent new things. We can invent new things. And we can invent new medicines. Invent new medicines. Most of the food that you guys like, I know that you guys like your Takis and your candy and stuff like that, and your sodas. Those were all made by people that were using chemistry. They were using chemistry to explore how to make those things. With hand lotions, you always have a chemist that's involved to make sure that it works well, won't react with your skin. Um, but you know, a lot of the little snacks you guys like, the Takis, the candy, those things are also made by what we call food chemists, who are chemists that will work in laboratories or even R&D kitchens to explore new ways to make things. But all of our products that we use, from tires to gasoline, chemistry is involved in some way to manufacture all that stuff that we need, that we use, and that we enjoy. And having an understanding of atoms and how they behave will definitely help you in the real world. Make sure that you guys are completing your packets. Make sure you study for your test, your quiz, and hope that you all do very well.